So we may encounter more complicated case than the previous one. Possibly you will see that we may compare two parameters against each other, two parameters of one variable against each other. Okay, so we can test if a sample variable is equal to another sample variable or not. For instance, in the previous case, we can see, say, if the wage for women is statistically significant than wage for men. So the null hypothesis is wage for man equals to wage for woman. So this, again, those are population. Okay, the population ones are those without hat, and the sample ones are those with hat. Hat is actually this one. The little triangle upwards, that's hat. Okay. All right, let's come back. So this can be rewritten as the difference between the wages equal to 0. So we are more used to the equal to 0 or equal to a certain value case. Okay, so this is how mathematically it is done. All right, and this is what we are doing. We are gonna use data analysis, t-test, two samples assuming unequal variances, because those samples are different, and it's very rare that their variances are just exactly the same. The level of convergence basically are exactly the same across the two samples. So it's safer for us to assume unequal variances. The chat box, the command box will be like this. Okay, so let's do this case. All right, let's look at this. So this is the overall thing, overall data, and we are looking at the wage of female versus male. So the first thing that we are to do, let's just uncheck them all. Okay, the first thing that we are supposed to do, say, let's go back to the original status. It's all messed up. Okay, so here it is ask you, the first question is to ask you the wage between male and female, are they the same? So it's the wage, and the distinguish is drawn by male and female. So the first that you're not supposed to do is to rank, to sort based on the difference. Okay. All right, we have this. Then what you are going to do is to go to data analysis, and t-test two samples assuming unequal variances. And here, variable range number 1, you are looking at male's wage, right? Because here, female equal to 0, that's male's wage. So we're gonna select all the way to the watershed. Okay, that's here. 275. Okay, and here after that, what we're gonna do is from 200 what we are gonna do is from 275, okay, to go to the bottom. 275, that's here. Okay, to go to the bottom. 276. So we're going from 276 all the way to 527. All right. And the hypothesis mean difference is 0. We assume they are the same. Okay. And here, the new worksheet is wage difference between sex. Okay. So that's here. So as you can see, what we should be looking at are the t-stat and p-value. Okay, the p-value looks like this. If you don't like it, what you can do is to change the format of cells into number. And here it's just 0. Okay, so t-stat, so here t-stat is much greater than 1.96. What does that mean? We should reject the null, which is woman's wage is no difference from men's at a 95% confidence level. Why is it 95%? Because we are comparing to 1.96, which is a 95%. Okay, and here the p value is even smaller than 0.01. Okay, then we can, of course, then 0.05. Okay, again, we can reject the null at a 95% confidence level. And it is even smaller than 0.1. We can take a step further. It is even smaller than 0.01. Okay, that means we can reject the null at a 1%, a 99% confidence level, which is also a 1% significance level. Okay, why is significance level the opposite of confidence level? Why do they add up to 1? Because the total probability is 1, right? And the p-value is actually looking at the distribution, which goes back to the world of probability. Okay, so the confidence level opposite is significant level. All right, so that's this example, testing 2 parameters. Let's look at one application questions. Do individuals who are married have the same level of education as those who are not married? So now the distinguishment is made on marriage, which is here, right? So what I would suggest is you can color them, and you're looking at education, right? So first, you need to sort your data per marriage. And then you're looking at education. So it's data analysis, test 2 sample, assuming unequal variances, and you're looking at the education. Okay, for married person, that's your default group. There was a mistake in there. It shouldn't be all 1. Oops. Okay, good. All right, let's go to data analysis. So these are unmarried person versus married person. Okay, so go to the top. So this is education of unmarried person. Marriage equal to 0. We're staring at the marriage column. Oh, well, we're here. And then the unmarried person, the education of married person. The marriage equal to 1. So the first group is unmarried. The group that we are working on now is married. And here the previous question is they have the same level. Then the hypothesis mean difference should be 0. There should be no difference between these two. And the new worksheet is the education difference between marriage. Okay. So here in this case, look at them. T-stat and p-value are what we should be looking into. We should be looking into the two-tail more accurately. So previously we should have also be looking into the two-tail data as well. Okay, so in this case, T-stat now its absolute value is 1.85, which is now smaller than 1.96. So we cannot reject. We cannot reject it now. And here, the p-stat is greater than 0.05. And again, we cannot reject now at 95% confidence level. Previously, it's the same at 95% confidence level. Okay. And here, what does that mean in context? In context, that means we do not believe the education statistically differs between the two marital groups. The difference is not significant. Okay, so that's how we do the statistical inference between two parameters or two subgroups, if you want.